Okay, let's try and go over this first Mabel test and try and solve the problems one by one. So problem number one, implement a procedure that can compute the value of recurrence relation x of n equal to 2 times x of n minus 2 plus x of n minus 1 for a given n with x1 given by this value and x2 by that value. Use the function to compute the sequence of numbers f of n from n equal 1 to 30 with 20 degrees of precision and plot the points. Okay, so let's get started. So in Mabel, it's always good to start out by restarting everything, so make sure we have a clean environment. We should use 20 degrees of precision, so let's start out by making sure we are doing that from the beginning. Just try and make things a little bit prettier. Okay, and we needed to create like 30 something, so let's make a counter for that somewhere. Could make it here. Okay, then we have this recurrence relation, and it looks like a thing that could easily be implemented using a recursive function. So let's call that function f. I can do it like a procedure. It's gonna take n as input, like this. I'm gonna end it like that, and then we're gonna say if n is equal to, let's see, 2, then we're gonna return the value of 1 minus 3.0 to make sure this is the square root. Just write it like this, just to make sure everything is in float and nothing gets evaluated as symbols, but everything stays numbers. Else if n equal to 1, then we need to return the value 1, it seems, like this. And if none of those cases occur, these two given values, then we need to use the recurrence relation, so we need to implement that. That means return, let's see, 2 times of f n minus 2 plus f of n minus 1, like this, semicolon. Let's see if this works out. Okay, so far so good. Okay, and let's see, so now we implemented the function. What else should we do? We should make a sequence of numbers. So let's make the x values sequence of n from n equal 1 to, again, let's see if that works out. That seems nice. And then we should compute corresponding function values. F values equal to, let's see, we can probably use map function for this. So how does that work? X maps to f of x. This probably need to be a list, I would imagine. Let's see if it works. This is running too slow. It's probably this recursive thing, so let's try and do an option. Remember here, could have rewritten it into an iterative version, but I'm just too lazy, and it's kind of easy to write up the recursive definition directly from the recurrence equation. So we're gonna stick with the making things easy and fast. Okay, like that. Gonna create x values, and there you go. So now we just need to do the plot. Plot of x values, f values, style equal to point is something like this, I think. Not quite. Let's just go and look in the help system to see if we can make out how we're gonna do this. Plot it as points. It's a point example somewhere here. Vector, vector, style, point. Okay, let's go back here and see what went wrong. It's probably because we need it to be like this. Let's see if this works. Okay, done. That was first assignment. Don't need this. Save our answer.